Let's see the next topic in general science, that is work. So before proceeding to the previous year questions, let's see what are the important topics that you should revise before going to your exam. You should know the definition, what exactly is a work, and what are the different types of work like positive work, negative work, and zero work. Afterward, you should be very thorough on the special cases where work done is said to be zero. Okay, there are certain conditions that we have seen in theory classes. Okay, afterward, you should be very thorough on the numerical part. Okay, in general science, physics, numerical are expected in the exam, and you should know the formula of the work and how work is calculated while lifting the object and while when object is moved. Okay, that is delta P. P is potential energy, delta Ke. Ke is kinetic energy. So when work is done while lifting the object and work done while moving the object, all such concept you should be very thorough. Okay, so the first question on your screen, which of the following work done does not depend on, these are the options: applied force, mass of the object, displacement, the angle between force and displacement. A very simple one, and if you know the concept related to the work, you can easily answer this question. Yes, those who have given option B, mass of the object, they are right. Work done does not depend upon the mass. Why? Because you know that work done is equal to force into displacement. Okay, that is the dot product. Okay, so work done depend upon the force vector and the displacement vector, but if you remove this dot product, it will become FD cos theta. Theta is the angle between force and displacement. Okay, and if you see the equation, there is no mass terminology, so that's why work done does not depend upon the mass. Okay, so some student might think that force is what mass into acceleration, so it will depend upon the mass, but that is wrong concept. Okay, because work is basically depend upon the magnitude of the force. Okay, so how much force is applied on the object, okay, not on the mass of the object. Okay, so the correct answer for this question is option B. And we have seen in theory classes what exactly is the meaning of work, and as I told you, the main one is the formula, that is work is equal to force dot product of S is what? Displacement, and it does not depend upon the mass of object. It is very generally asked in the exam like RRB. And again, a most confusing one is that it is a scalar quantity. How it is a scalar quantity? Because this is a dot product, and the dot product of two vector is always scalar. Okay, so don't confuse that. If force is vector quantity, work done will also be vector. Since it is dot product with the displacement, so it will be a scalar quantity. Okay, and finally you should know the units of work. The SI unit of work is joule. This is a common unit, but sometime in exam he can ask you about Newton meter. How this Newton meter has come? The unit of force is Newton, unit of displacement is meter, so it is Newton meter. So 1 joule is equal to 1 Newton meter. Coming to the CGS unit, erg, and 1 joule equal to 10 power 7 erg. Okay, so these are the few previous year pointers that we have seen repeatedly in the exam. You should be very conceptual about these pointers. Okay, let's see the next previous year question. A moving car faces the wind in opposite direction. What will be the work done by the wind on the car? Okay, so suppose this is a car. Okay, car is moving in this direction, so force is applied on this direction. Okay, So car is moving in this direction and wind is moving in the opposite direction. So this is wind. Okay, so since force is applied in this direction and wind is trying to displace the car in this direction, so the angle between the force and the wind, if I make force here, the angle between force and wind is what? 180 degree. And just now we have seen that work done is FD cos theta. And what is force? F, D is displacement, cos theta. Here theta is 180. Okay. So in that case, cos 180 is -1. So it will become minus FD. So the work done will always be negative in this case. Okay. So option A, those who have given, they are right. So whenever the displacement is in opposite direction to the applied force, the work done is negative. Okay. So we have seen the formula of the work done. Work done is Fs cos theta or Fd cos theta, where theta is the angle between force and displacement. And there are three types of work: positive work, zero work, and negative work. Positive work, if the angle is acute, if the theta is less than 90, then it is a positive work. If it becomes 90, that is perpendicular, then it is said to be zero work. And the perfect example is that when you are holding a bag while standing, you are not doing work, even you are lifting the work. Okay. The next one is negative work, when the angle is obtuse, that is greater than 90. Okay, in that case, you know, it become theta become negative in that case. Okay, so the total will become negative. So the maximum we have seen, it is 180. It is also straight angle but close to the obtuse angle. It is greater than 90, so it will become minus Fs. Okay. So it is generally seen in the friction and brake kind of example where the work done is negative. And one more important pointer is that the special case of zero work. So generally in ask, he can ask you the cases where work done is zero. So there are three conditions. If you see the formula, there are three conditions. If force is zero, means a block moving in the frictionless table. Okay, so if there is like no force acting on the body but displacement is there. Okay, when displacement can be there? If it is frictionless, there is no friction, that book is moving by its own, in that case the work done is said to be zero. But practically this case is not possible. Okay. The next one, S is zero. S is what? Displacement. If displacement is zero, work done is again zero. Okay. So suppose if person is pushing a wall and he is not able to move the wall, then work done will be zero. The next one, a weightlifter holding 100 kg. It looks like that 100 kg he is doing some work, but he is not moving at all. Okay. He is holding that mass, so displacement is not there. Again, in that case, work done is zero. In physics, remember, in physics work done is zero. Next one is circular motion. So you know circular motion is like this. So from here to here the work done is zero because displacement becomes zero, right? So in that case also the work done is said to be zero. And this is very important: when the angle between force and displacement is 90 degree, then the work done is zero. And the perfect example is coolie carrying the load on his head and person carrying the briefcase. Okay, in that case, even though it appears they are doing work, but in physics it is said to be have no work or zero work done. Okay, let's see the next question. The work done by the force is positive when what? Just now we have seen that work done of the force is positive if displacement occur there. Okay, so if you see all of these option C, there is no displacement, so this is wrong. There should be displacement, then work is said to be positive. And if displacement is in opposite direction, then work done is become negative. And if work done, displacement is perpendicular to the force, what happened? The angle become theta become 90. In that case, again work done is 0. In this case, it is 0. So we are left with option A when displacement occur in the direction of force. Okay, so if force is applied here and displacement is also in this direction, so work done is said to be positive. So those who have given option A, they are right. Let's see the next question. If a person pulls a trolley up to the distance of 10 meter with force of 15 Newton, what will be the work done by him? Okay, this is a numerical part, and in exam you can face numerical related question. Okay, so for numerical you should know the formula is work done equal to F d cos theta or F into S into cos theta. Okay, so in this case you can ignore theta. You can say it is very zero. It is, you can say it is in the same direction. Since it is in the same direction, the angle between force and displacement is 0, so cos 0 is 1. So work done will be force is what, 50 Newton, and displacement is 10 meter, so it become 500 what, as we have seen the unit of work is joules, so 500 joules. So option B is the right answer. Again a numerical, and this time in this question you need to calculate the distance. Okay, so a bus was running with a force of 4000 Newton and the work done by the bus is 2000 joule. What is the distance covered by the bus? Okay, so this is force applied and this is a work done, and you need to tell the distance. Again, since displacement and the direction of force is in the same direction, so theta is 0, so work done will be F into S. Okay, cos 0 is 1. Okay, so F is what, 4000. You need to calculate the displacement and work done is 2000. Okay, so distance will become 2000 divided by 4000. It will become 0.5 meter. Okay, so option D is the right answer. Let's see the next, again a numerical. Here you need to find the angle between the force and displacement. A very good question. I will mark it as important. It is not straightforward. So the force applied on the object is 50 Newton. Okay, 20 Newton, sorry, displaces the object through 2 meter. So displacement S or D is 2 meter and does a work of 20 joule. Okay, so you need to find the angle. Again the same formula, work is equal to F into S into cos theta. What is the work done? 20 joule. What is the force? 20. What is the distance traveled? 2 into cos theta. So 20 got cancelled. You have 1 by 2 is equal to cos theta. So theta is cos inverse 1 by 2 at 60 degree. The cos theta is 1 by 2. So the angle between force and displacement will be option A, 60 degree. Okay. Let's see the next question. A porter raises 12 kg object from the surface of earth and put on 1.5 meter above the surface of his head. What will be the work done on the object? Okay, you need to be very cautious. He is asking work done on the object. Okay, so there are two cases, work done on the object and work done by the gravity. Okay, so basically in this question the concept is that work done is equal to change in potential energy. Okay, so what the question says that the luggage was here, so it was raised up to 1.5 meter, okay, of mass 12 kg. Okay, so it was raised from 1.5 meter to the head, that is 12 kg, on the surface. So you need to calculate the work done which was done on the object. So potential energy is basically change, and you know the potential energy formula is mgh, and m is what, 12 kg, g he is saying that you use 10, and h is 1.5 meter. Okay, so 1.5 by 10, so 12 into 15, it becomes 180 joule. Okay, so those who have given option C, they are right. Okay, so here you need to remember this formula. Work done is change in potential energy. Okay, so there are two other formula beside Fs cos theta. It is change in potential energy and change in kinetic energy. And if he asks work done on the object, your answer should be positive mgh, and work done by the gravity, since gravity is acting downward, so your answer should be minus mgh. Okay, and change in kinetic energy, as you know, kinetic energy is half mv square. So velocity is changed from one initial state to final state, v2 square minus v1 square. Okay, so these formula are very helpful for this chapter. Let's see, an object of 1 kg raised 10 meter above the surface of earth, then work done by gravitational force will be what? Okay, so in this question you need to calculate the work done by the gravitational force, not on the object. Okay, so in this case the answer will be negative, since he is asking work done by the gravitational force, so answer would be negative. So you are left with option C, option B and D, because these are negative. What will be the work done? It is change in potential energy. Potential energy is what? Minus mgh. What is m? M is 1, g is 10. He is taking 9.8. Okay, I will take 9.8. H is 10. Okay, so it will become minus 98 joule. Okay, so option D is the right one. Okay, so don't go with option A. Okay, since the question says work done by the gravitational force, it should be negative, and after calculation it is computed as minus 98 joule. Let's see the next question. In this question, the work done you need to calculate with the help of change in kinetic energy. Okay, so change in kinetic energy is what? Half m v2 square minus v1 square. Okay, so mass is what? 4 kg, so 1 by 2 into 4. Velocity is what? It changed from 10 to 5. Okay, so 10 square is 100, 5 square is 25. Okay, so if you calculate 75 into 2 is what? 150 joule. Okay, so 150 joule is the right answer for this question.